Hello, this is Sujit. Welcome to Physics 2020. So today we are going to discuss another very important topic that is multiplication of vectors. So we are discussing the chapter that is motion in a plane, the third chapter of NCERT, motion in a plane. So what are the things we have discussed in this chapter? So in the first section we have discussed the fundamentals of vectors. In the second section we have discussed the addition or combination or resultant of vectors. So in that topic we have discussed the triangle law of vectors and parallelogram law of vectors, the concepts of triangle law of vectors and parallelogram law of vectors. In the third section we have discussed the numericals of triangle law of vectors and parallelogram law of vectors. So totally 10 problems we have discussed. So in the fourth topic we have discussed unit vector, the concepts of unit vectors and resolution of vectors. In the fifth topic we have discussed another 10 very important problems of that is resolution of vectors. So in this section we are going to discuss that is multiplication of vectors. Okay, multiplication of vectors. So the multiplication of vectors can be done in three ways. Okay, three ways. So first one, that is multiplication of vector by scalar. Okay, multiplication of vector by scalar. So second one, scalar product of vectors, scalar product or dot product. Scalar product or dot product of vectors. So third one, vector product or cross product of vectors. So these are the three ways of multiplying the vectors. So the first one, that is multiplication of vector by a scalar. So consider a vector A vector. Okay, A vector. So multiplying this vector with any scalar. So such as lambda is a scalar. Okay, lambda is a scalar. So how we can multiply? That is lambda into A vector. Okay, lambda into A vector is equal to lambda A vector. Okay, just multiplying. That is multiplying the magnitude of this A vector with the scalar and writing the result as a vector 1. Okay, so if you multiply a vector with a scalar, you will get a vector quantity only. You will get the result as a vector quantity only. Clear? So for example, A vector is equal to 5. Okay, 5 Newton. Okay, 5 Newton. So the direction is south direction. Okay, south direction, A vector. So what is 5A vector? Okay, 5A vector. So 5A vector is equal to 5 into, that is 5 into 5 Newton, that is south. Okay, south. That is the answer. So that's equal to, that is 25 Newton. 25 Newton south. So this is the way of multiplying a vector with a scalar. So if you multiply the vector with a scalar, you will get a vector quantity only. Okay, that is very important. Then next is scalar product or dot product of vectors. So this is multiplying two vectors. Okay, two vectors. So consider two vectors, A vector and B vector. Okay, B vector. So if you multiply two vectors, that is A vector and B vector, using this scalar product method, so you will get a scalar only. Okay, you will get a scalar, that is A vector dot B vector. Okay, so we will get, that is we write like this, that is multiplication, that is two vectors A vector dot B vector. That's why it is called a dot product. Okay, so you will get a result as scalar. Okay, scalar, not vector. If you multiply two vectors, you will get a result as scalar. So another multiplication of vectors, that is A vector two vectors A vector and B vector. So they are multiplied, A vector cross B vector. That's why it is called a cross product. So you will get a result as vector only. Okay, so this is the three ways of multiplying the vectors. So in this section we are going to discuss the scalar product or dot product of vectors in detail. So what is the way of multiplying two vectors in a scalar product method, and what are the properties of scalar product? Okay, these are the things we are going to discuss in this section. So scalar or dot product, scalar or dot product of vectors, scalar or dot product of vectors. So first the definition: scalar or dot product of two vectors, A vector and B vector, is defined as the product of the magnitudes of vectors A and B. Okay, A vector and B vector, and cosine of the angle between the vectors. So this is the definition. Okay, so scalar or dot product of two vectors, A vector and B vector, is defined as the product of the magnitudes of the vectors A vector and B vector and cosine of the angle between the vectors. Okay, consider two vectors. For example, this is an A vector. Okay, A vector, and this is a B vector. Okay, B vector, A vector and B vector. So which is inclined at an angle theta, or theta is the angle between A vector to B vector. Okay, B vector. So according to the scalar product of these vectors, that is, we can write A vector dot B vector is equal to, it is defined as the product of the magnitudes of the vectors A vector and B vector. What is the magnitude of the vectors A vector? So that is modulus of A vector. What is the magnitude of the vector B? That is magnitude of B vector into cos theta, that is cosine of the angle between the two vectors. So what is the angle between the two vectors? That is theta. So theta is measured, if you calculate, that is A vector dot B vector means theta is measured from A vector to B vector. Theta is measured in the anti-clockwise direction. That is very, very important. Okay, anti-clockwise direction. Okay, so A vector dot B vector is equal to modulus of A vector modulus of B vector, that is magnitudes. Okay, magnitudes of the vectors A vector and B vector and cosine of the angle between the vectors. Okay, so A vector dot B vector, what is modulus of A vector? That is A. What is modulus of B vector? B cos theta. So if you take the modulus of a vector, that is, we will get only magnitude. Okay, the vector sign will change. Okay, so AB cos theta. So here A is a scalar, B is a scalar, and cos theta is also a scalar. So that's why if you are taking the dot product of two vectors, so we will get a scalar only. Okay, scalar product. That's why it is called a scalar product. Okay. Then physical examples of scalar product. Scalar product. So in physics, the scalar product plays a vital role. So for example, what if work done? So work done. So work done W is equal to, what is the formula? That is force into F vector dot displacement vector. So force into displacement. So force is a vector quantity, displacement is a vector quantity. So we are taking the dot product among these two vectors because work done is a scalar quantity. Work done is not a vector, work done is a scalar quantity. Okay, so scalar product can be applied here, that is can be the first application, that is work done. So if you are multiplying, that is taking the dot product of two vectors, not the cross product. So another instantaneous power, okay, instantaneous power P, okay, so that's equal to formula, that is F vector dot velocity vector. Okay, velocity vector, force into velocity. So force is a vector quantity, velocity is a vector quantity, but power is a scalar quantity. Okay, third one, magnetic flux phi is equal to B vector dot A vector. So magnetic flux is equal to the product of magnetic flux into, that is magnetic field into area vector. So okay, B vector dot A vector. So B is a magnetic field is a vector quantity, area is a vector quantity. So if you take the dot product of these two vectors, so we will get magnetic flux, it is a scalar quantity. So these are the some of the physical examples of that is dot product. Okay, dot product. So understand what is scalar product, what is meant by scalar product, how we can do the scalar product, and what are the physical examples of scalar product. Okay. Then properties of scalar product of vectors. Properties of scalar product. Properties of, first point, scalar product is commutative. Scalar product is commutative, that is A vector dot B vector is equal to B vector dot A vector. Okay, B vector dot A vector. So this is A vector, this is B vector. So theta is the angle, okay, theta is the angle between these two vectors. So A vector dot B vector is equal to AB cos theta. So if you find A vector dot B vector means the angle from A vector to B vector, okay, A vector to B vector, which is measured in the anti-clockwise direction. So theta is the angle, okay, theta is the angle. So take it as equation number 1. What is B vector dot A vector? B vector dot A vector is equal to BA. So what is the angle between? If you find B vector dot A vector, the angle from B vector to A vector, which is measured in the anti-clockwise direction. Okay. So you don't take, that is B vector dot A vector, you don't take that is theta is the angle. No. So if you find B vector dot A vector, the angle from B to B to A, which is measured in the anti-clockwise direction. So if this is theta, means what about this angle? That is 360 minus theta. Okay, 360 minus theta. So BA cos 360 minus theta. Okay, 360 minus theta. So that's equal to, so BA we can write that is AB. So cos 360 minus theta, that is cos theta only. Okay, cos theta. So take it as equation number 2. So we will get A vector dot B vector is equal to AB cos theta. B vector dot A vector is also we get, that is AB cos theta. So from 1 and 2, from 1 and from 1 and to 2, we can write that is A vector dot B vector is equal to B vector dot A vector. So that's why it is called commutative. Okay. So the next point, second point, the dot product is distributive over addition. Okay, distributive over addition. That is A vector dot B vector plus C vector. So we can write that is A vector dot B vector plus A vector dot C vector. Okay. So this is called A vector, that is distributive. Okay. That is dot product is distributive. That is the second property. Then third property, if two vectors are perpendicular, third point, if two vectors are perpendicular, then dot product is zero. Okay, dot product is 0. So consider two vectors. This is A vector and this is B vector. So what is the angle between these two? It is 90 degree. Okay, 90 degree. 90 degree. Okay, so what is A vector? A vector dot B vector, that is equal to AB cos theta. Okay, cos theta. So we can write that is AB cos 90. Okay, AB cos 90. So cos 90 0. Okay, cos 90 0. So that's for total it is 0. That's why if two vectors are perpendicular or they are inclined at an angle 90 degree, so the dot product is 0. If two vectors are parallel and act in the same direction, then the dot product of dot product of two vectors. Dot product of two vectors is maximum of positive magnitude. Positive magnitude, or two vectors is dot product of two vectors is positive maximum. If two vectors are parallel, parallel, and they are acting in the same direction, this is A vector and this is B vector, B vector. So what is the angle between these two vectors? If two vectors are parallel, means the angle between the two vectors is 0, 0. So A vector dot B vector is equal to AB cos 0, AB cos 0. So that's equal to, what is cos 0? Cos 0 is 1, so AB. So that is maximum, that is the dot product is maximum. Then fifth point. Fifth point. If two vectors are parallel and act in the opposite direction, then the dot product is negative maximum. So two vectors, one vector is acting, so they are also parallel vectors. So this is A vector and this is B vector, B vector. So from this point they are acting, but they are acting in the opposite direction. So what is the angle between the two vectors? That is 180 degree. So A vector dot B vector is equal to AB cos theta, that is equal to AB cos 180 degree. What is cos 180? Cos 180 is minus 1. So that is AB into minus 1, that's equal to minus AB. So that's why two vectors are parallel and act in the opposite direction, then the dot product is negative maximum. So we will get the negative maximum magnitude, but negative, it is negative. Negative maximum. Clear? Sixth point. The dot product of a vector, with itself is square of its magnitude. The dot product of a vector with itself is square of its magnitude. That is, we have a vector, A vector. A vector. So we have to find, that is A vector dot A vector. That is the dot product of a vector with itself. A vector dot A vector. So that's equal to modulus of A vector modulus of A vector into cos theta. So theta is the angle between A vector and A vector. What is the angle? That is 0. So that is modulus of A vector A, modulus of A vector A, cos theta, that is cos 0, that is 1. So we will get, that is A into A. So that's equal to A square. A square. So that is the mean. The dot product of a vector with itself is square of its magnitude. So which can be also written as that's equal to a vector modulus of a vector square. Okay, a vector square. So this result we will use, that is a vector modulus of a vector square is equal to a square modulus of a vector square. So this is equal to, this means definitely this is equal to a vector dot a vector. So a square is equal to, we can write that is a vector dot a vector. Okay, so these two results we will use for the problems. Okay, problems. So this is the 6th point. Then 7th point. So the dot product of two similar unit base vectors. Okay, unit base vectors is 1 and 2 different unit base vector is 0. So the dot product of two similar unit base vectors is 1 and two different unit base vector is 0. What is mean by unit base vector? That is orthogonal unit vectors. Okay, orthogonal unit vectors. A rectangular coordinate system. Okay, rectangular coordinate system. So this is the x-axis, this is the y-axis, and this is the z-axis. Okay? Z-axis. So I cap, j cap, and k cap are the unit vectors. Okay, are the unit vectors along the x-axis, y-axis, and z-axis, which is used to represent the direction of x-axis, y-axis, and z-axis. So these vectors are called orthogonal unit vectors or base unit vectors. Okay, base unit vectors. So this is the origin. So this is I cap. This is j cap. This is k cap. Okay, k cap. So these are the unit vectors. Okay. Unit vectors along x-axis, y-axis, and z-axis. So the dot product of two similar unit vectors, that is I cap dot I cap, is equal to 1. Okay. So how it is 1? That is I cap dot I cap. So we can write, so two similar unit base vectors, that is I cap dot I cap is equal to 1, j cap dot j cap is equal to 1, k cap dot k cap is equal to 1. So that is given. So the dot product of two similar unit vectors, I cap dot I cap, j cap dot j cap, k cap dot k cap is 1, always 1. So how? That is I cap dot I cap is equal to modulus of I cap, modulus of again I cap into cos. So I cap dot I cap. So what is the angle between I and I? That is 0. So cos 0. So that's equal to modulus of I cap. It is a unit vector, unit magnitude. So 1 into cos 0 1. So we will get 1. Okay, similarly j cap dot j cap, modulus of j cos 0. So the angle between j and j, that is 0. So cos 0 again 1. So we will get 1. Okay, k cap dot k cap is equal to 1. Okay, so the dot product of two similar unit base vectors is 1. And two dissimilar unit vectors or two different unit vectors, so such as I cap dot j cap is equal to 0, j cap dot k cap is equal to 0, k cap dot I cap is equal to 0. Clear? So two different unit vectors. If it is different, I dot j, j dot k, k dot I is equal to 0. So how it is? That is I cap dot j cap is equal to modulus of I cap modulus of j cap into angle between I and j, I to j. What is the angle? 90 degree. Okay, 90 degree. So cos 90. So what is cos 90? 0. So that's equal to 0. J dot k, j to k. So the angle between these two, that is 90 degree. Again 0. Cos 90 0. K dot I, k to I. So the anti-clockwise direction. What is the angle? That is 90 degree. So cos 90 0. Okay. So the dot product of two similar unit base vectors or orthogonal unit vectors. Okay, orthogonal unit vectors is equal to 1 and two different unit base vector is 0. Clear? So the next is if a vector is represented in a rectangular coordinate form. If a vector is represented in a rectangular coordinate form. For example, A vector is equal to Ax I cap plus Ay j cap plus Az k cap. And B vector is equal to, that is Bx I cap plus By j cap plus Bz k cap. Okay, k cap. What is A vector dot B vector is equal to Ax into Bx, Ax into Bx, I dot I 1 plus Ay into B1, J dot J 1 plus Az into Bz, that is Bz. What is k dot k? That is 1. So this is the dot product of two vectors. Okay, two vectors. So what is the angle between the two vectors? How we can find the angle between the two vectors? So we know that A vector, so 9th point. So the angle between the two vectors, A vector dot B vector is equal to modulus of A vector modulus of B vector into cos theta. Okay, so the cosine of the angle theta we can find. So cos theta is equal to formula. So cos theta is equal to A vector dot B vector divided by modulus of A vector modulus of B vector. Okay, so this is the formula to find the angle between the two vectors. So the cosine of the angle theta between the two vectors can be found by the formula, that is cos theta is equal to A vector dot B vector divided by modulus of A vector divided by modulus of B vector. Okay. So if the vectors are in the rectangular coordinate form, so we can write this formula, that is cos theta is equal to, what is A vector dot B vector? Ax Bx plus Ay By plus Az Bz divided by square root of modulus of a vector a x square plus a y square plus a z square into square root of modulus of b vector bx square plus by square plus bz square. So this is the formula. Okay, formula. So these are the properties of dot product. Okay, dot product. So in this section we have discussed what is a dot product, how to find out the dot product, and the properties of dot product also we have discussed. So with this I wind up this session, and the next topic we will discuss the 10 problems of dot product. Stay tuned. Bye.